let us now see how does it works. Let's solve the following example. There is a police department that has statistics on several types of crimes committed in two different areas. And so there are two areas, namely Area A and Area B. And there are three types of crimes they are interested in, namely burglaries, robberies, and car thefts. And so we can fill in the contingency table. As we know that number of burglaries for the first area was 30, for the second one 20, that means totally 42, and number of robberies for the first area was 90, for the second one 23, that is also totally 42, and number of car thefts was for the first area 6, for the second 14, that is totally 20. And so total number of crimes for the area A is 55, for the area B is 49, that means totally 104. So this is the contingency table we will deal with. And so they are interested in question, can we assume that there is no relation between area and the frequency of crimes of different types? So can we say that there is no relation or no association between the area and the crime type? So as we see a contingency table, what we do, we calculate the chi-squared statistic. So we say, first we say what hypothesis we are going to test. So we say that let us test a hypothesis that for all i's and j's, P of AI intersection Bj is equal to the P of AI times P of Bj. That there exists such I and j such that P of AI intersection Bj is not equal to P of AI times P of Bj. So the first means no association, no relation. And the second means that there is a relation of some kind. So what we need to calculate the chi-squared statistic. So how this is done? We say that H is equal to the sum of 6 terms, of 6 elements. So we calculate this element of this sum for each cell of this table. So we have 2 areas and 3 types of crimes. So we have 2 times 3, 6 cells in the inner part of this table. So the first element is 30 minus 55 times 42 divided by 104 squared divided by 55 times 42 divided by 104 plus second element for the second cell, 19 minus 55 times 42 over 104 squared divided by 55 times 42 over 104. And we do so for all other cells. So for the last one, for this one, we have here 14 minus 49 times 20 divided by 104 squared divided by 49 times 20 over 104. So, if we calculate all these for all 6 cells of the table and add them, so the final answer, not the answer, the value of this statistic, the value of H, is 10.98 approximately. So if we do all necessary calculations, we'll get that H is 10.98. So then we say that under null hypothesis, so if HO is true, then H follows chi-square distribution with number of degrees of freedom equal to 2 minus 1 times 3 minus 1, that is 2. So we have, in our case, we have k equal to 2 and m equal to 3. So here we have k 2, k equals 2, and m equals 3, as we have 2 areas and 3 types of crimes. So here we have 2 minus 1 times 3 minus 1. So that means that we have here chi-square distribution with 2 degrees of freedom. In these problems, we always have a right-tailed critical region. So this is critical region, this is the acceptance region. And so the border is the quantile of the chi-square distribution with 2 degrees of freedom of the level 1 minus alpha. Let us assume alpha, standard alpha, alpha 0.05. In this case, here we have chi-squared quantile with 2 degrees of freedom of the level 1 minus alpha, that is 0.95. And we can find this quantile using the table of the chi-squared quantiles. And if we open a table, we will see that this is equal to 5.99. What does it mean? It means that H is in critical region. So H is somewhere here. H that is equal to 9 to 10.98. So H is in the critical region. This means that the null hypothesis is rejected. This means that the null hypothesis is rejected. So the answer to the question is no. So they asked, can we say that there is no relation? Can we say that there is no relation between the area and the crime type? And this was the null hypothesis, that there is no relation. And the alternative one is that there is a relation, and so we reject the null hypothesis in favor of the alternative one. So we say that we cannot say that there is no relation between the area and the crime type at the 5% significance level, at the significance level of 0.05. So the answer is no, we can't. At the 0.05 significance level. And finally, another thing we may be interested in is how strong this relation is, how strong this dependence is if we measure it with this scale from 0 to 1. And for this purpose, we can use any of the normalized coefficients. So I gave you several formulas. For example, let us use the Cramer coefficient. So the formula is that the Cramer coefficient is equal to square root, and under the square root we have H statistic, that is 10.98 divided by n. N is 104, and multiplied by minimum of two values, k minus 1 and m minus 1. So minimum of 2 minus 1 and 3 minus 1. That is 1, this minimum. So, and finally, if we calculate this, so this minimum simply just disappears as it equals 1. So it is 10.98 divided by 104 and square root of all this. And so the final answer is 0.32. So this is the Cramer coefficient for this contingency table. So we see that there is a relation, but not so very strong. The coefficient is less than 1/2, so it is closer to 0 than to 1. So we can say that there is a dependence, a relation, an association, but not so very strong one. So if we look at the table, we can say that yes, we see that, for example, number of burglaries is higher for area A than for the area B, and number of car thefts is lower for the area A than for the area B, and number of robberies is almost equal. So we see that burglaries are more common to the area A and car thefts are more common to the area B. So this is the relation, the relationship between these two, the area and the crime type. And in numbers, this can be expressed with this coefficient. So we say that there is a relationship, but not so very strong.